All right, hey, last video of content for our test that'll show up next week. So here's the last bit you need to know. We're talking about bond enthalpies now. So the specific making and breaking of bonds will have energy values associated with that process. So breaking bonds is endothermic. In order to do that, you need energy to separate the atoms in a bond. And after the broken results, we'll have a higher energetic state. And making bonds is exothermic. So bringing atoms together in a favorable manner releases energy to their surroundings and lowers the energy of the atoms in the reaction. Bond enthalpy is the energy to break 1 mole, and that's an important term. So energy to break 1 mole of bonds in a gaseous state in a chemical reaction. We say gaseous so that way the IMFs are ignored. And finally, the energy change in reaction down at the bottom here is just the energy of bonds broken minus all of the energies formed. So that little squiggly line in front just means the sum of bond energies broken minus the sum of bond energies formed. Now, this might sound a little funky, but it's really easy in the application. So I'll show you how you'll do that. Now, this in general, this chart that you'll see down here, this will be available to you by means of the data booklet through IB. So there will be a whole section where you can see all of these bond types and the energies that are associated with them. Here's a brief little bit of reading at the beginning of the worksheet that I think is valuable to you, but I'm just going to jump right into one example. So here I'm looking at example number 1, where we have hydrogen and chlorine gases rearranging to make 2 hydrochloric acids, or 2 hydrogen chlorides. Now I will see that my HH bond here has an associated energy of 436 kilojoules per mole. So that is one of my atoms. So I'll say the bond's broken. So I'm breaking this bond, and with that I have a 436 kilojoule energy value, plus my chlorine-chlorine bond, which is over in this column at 242 kilojoules per mole, 242 kJ. All right, so that is the bonds broken side of things minus the bonds formed. So I have HCl, HCl. So I have 2 hydrogen chlorides or hydrochloric acids. Now here is my value up here of 431. Now I have 2 of that 431 kilojoule value, right? And then from there, I will get my final answer. I don't have my calculator handy, but I'll let you decide what the result is. And remember, if it's positive, it will be endothermic for the process, and if it's negative, it will be exothermic. A couple of things to note about this process is, number 1, be careful with your stoichiometry. Be careful with coefficients. And so what I mean there is that you have to remember that when you are thinking about 2 hydrogen peroxides, you have to remember that whatever values you're getting, you must multiply by 2. Okay? The second reminder is, don't forget that there's multiple bonds inside of some molecules. So here, when we have more complex structures, I'll use methanol as an example. C and OH, right? So there are 3 carbon to hydrogen bonds here, 1 carbon to oxygen bond, and 1 oxygen to hydrogen bond here. So there is quite a bit of enthalpies for you to look up here. So there will be 3 times the CH bond. There will be plus 1 times the C to O bond, and there'll be also plus 1 times the O to H bond. And that would be the breaking all of these bonds for this one molecule. So you have to be really, really careful with that. And the last thing to remember is the general formula says that the sum of bonds broken minus the sum of bonds formed. So here, there could be multiple bonds that are formed, but you have to remember that you're subtracting all of that value. So maybe your value might have many calculations where you're doing x plus y, and then you have some other enthalpy where it's some new values of z plus q, I'm making these values up, plus some other values, right? You have to remember that this negative makes all of this term negative. So don't get caught up in saying that this is all positive. So you go negative plus, 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 plus. You have to use your negative. So I would usually get them as answers like this up at the beginning, where you have the bonds broken minus the bonds formed. Get a sub answer for each side and then do your final calculation.